8.5 years there. And I was tech lead for the back end of the practically all PubSub infrastructure of Amazon. I think Simple Queue service still uses kind of the design of the storage system I built. And then later I was tech lead for the Simple Workflow service, AWS Simple Workflow. And I also worked Google, Microsoft. And then we worked at Uber, and at Uber we started this project 6 years ago. Like 6 years ago it actually went to production. We started a little bit earlier. And 3 years ago we started the company. But it's open source, MIT license, so we'll talk about that. So we are an API. We are talking about like API conference. We're talking about APIs. And I will talk about mostly RPC here, but obviously it maps to almost any kind of other API technology we are talking about here. And the basic idea is that we have some call, which calls some function, and we do request to another process. That process invokes some other function which processes your request, whatever business logic you have, and at some point sends request like response out. And my question would be, why we cannot really have these APIs to last longer? Because really we talk about API gateways, we talk about all the technologies, but they become useless as soon as we go beyond a few seconds. You really cannot say, okay, I will have RPC call for 30 minutes, or I'm not even talking about 30 months. And the main problem is failure, obviously, that your server can fail. And if it fails, and if it's short-lived operation, you can deal with that. And the way we are dealing with it, we do retries. And everybody knows about retries, so everybody knows about idempotency, I hope. And we kind of do retries. And it works. Problem is that what happens if client fails? And very frequently, we can have another client which will retry, client failure, which will retry, whatever. But this works up to the point. There are a lot of use cases when your client cannot just, there is no external caller, right? Like there is something going on and you actually need to make a call and there is no magical retry kind of coming from outside. And what do developers do? We usually use some sort of persistence. Like most common one is queues, but you certainly can, a lot of people just use databases as queues. They just put records in database, then they poll for records which are ready, or they use some sort of kind of different technology. But at the end, queue is probably the most used one as soon as you have something which can kind of survive client failure. And I think this kind of my main point is it's mostly about client failure. And it's not about, because people sometimes talk about like duration of the call, like all long-running calls versus like short-lived calls. And it's not about how you invoke the API, because you can absolutely have async invocation of a short-lived function. But it's all about state. It's about what happens when your process which calls into some external API fails and how you deal with that. And when you have a queue, if client fails, message will be usually kind of, it's persisted in the queue. We are talking about durable queues. Then usually you will get that message back. But the problem is that at this point, you don't have this nice API call anymore. Like you didn't call something, you blocked on that, and you waited for that. At this point, you have a callback, which will be like, oh, on message, on whatever, and technically you can map to a specific function. So you get this callback, and then you're a new process, so you don't have any context of the call. So at this point, you need to look at that message and say, okay, what's going on? What do I do with this message? And the way we deal with that, usually we add a database. So practically, before calling something, putting message in a queue, we update the database saying there is outstanding transaction. Then we get a message, we load that state out of the database, and we do some state transition. So our code is usually just a bunch of callbacks, kind of trying to deal with those queues. And there are a lot of complexity around that. I'm not even talking about things like there is no transaction between the database and the queue. So when you update database and then put stuff in a queue, you can end up in bad state because what do you do first? Do put message in a queue or update the database? If you put message in a queue and update database, the message reply can be delivered by the time before your message committed. It's a very common scenario because database commit can be slow and you don't have context, and all bad things happen there very frequently. And everyone who tried to really troubleshoot system at scale knows that. So other problem is that there is no really guarantee here that reply will come, at least in the time you care about. So you make a request, you put stuff in a queue, then server which processes the request dies for whatever reason, because maybe it's not just short handler, takes time to process things. and the message doesn't get delivered. And how do you do timeout in such a system? You practically need to have records in database with certain timestamps. They need to poll database for messages which are not required some handling. Databases hate this type of polls. They don't scale for that. And or you need to have separate timer service. Does anyone know very good scalable timer, open source timer service, by the way? I don't think there is one. So it's always a problem. So, and I don't want to go there. We can talk about a lot of complexities around that. And the worst part is, like, there is no good API. Yes, there are API proposals to do asyncs and messages and whatever, but they are not even close to the normal APIs we are used to, which is like, okay, we get nice request, we get nice response, and this is timeout I'm willing to wait, and there is certain semantic of that API. And as soon as we go beyond a few seconds, we lose that. Queues don't help there. And, you know, standard answer which we see in the books, we see everywhere, we talk about enterprise patterns, we have a bunch of queues. And I took it from some website, I just Googled, okay, queue-based architecture, and gave this nice picture, which looks nice, and architects love nice pictures, but in real life, it's always like this. It's like duct tape architecture, right? Like we glue things together, we put queues, we put databases, it grows organically, like there are no real APIs there, just like messages in the queues which can change anytime. And this is what we have to deal with. And like I call it queue hell, but there are various variations of these architectures all over the place. I've seen that 1,000 times from Amazon, where we started 15 years ago doing these large-scale architectures to like a lot of companies. And there are other existing solutions. Certainly, you can poll for results. You can do long polls. We can do webhooks with different type of callbacks. But technically, they'll have the same issues. That you lose context when client restarts. You need to deal with that. There are all sorts of issues. And it ends up in messed up developer experience. Practically every time we go beyond single request reply, our developer experience like 10x worse, 100x worse than developer experience of just doing synchronous services. That is kind of our life now. So going back to how can we solve that? And if you think about out of the box, what would be the ideal solution? An ideal solution is actually very simple. You just create client which cannot fail. Right? And I probably can stop talk right now because I told you everything, and you just assume that not failing clients are awesome. And if server doesn't fail, it's even better, right? Because then your life becomes even better. And actually, let me introduce one abstraction which can help us go through that. And it's abstraction. We are not talking about software, whatever. It's just like transaction is an abstraction, very specific implementation of an abstraction. So imagine we have abstraction I call durable execution. And the idea of durable execution, it's a piece of code which cannot fail. How we do that? Like, do we have this imaginary ROM memory, like memory which is like super fast and never fails and persistent, or you do something else, or it's just magic? It doesn't matter. But like, let's think about this as an abstraction. So what will happen is that there is no failure in the middle. So like, if it runs on the process, like somehow this abstraction survives process failures and keeps running as it is running. And which also means that all state of that thing should be durable. So it means that every variable practically is a database write, at least logically. So it means that you need to actually persist anything, and you need to read from database, you need to write to database. You just say, oh, my variable is always durable, so there is no database requirements, because there is guarantee that this code will keep executing in the presence of like whatever failures we have in our system. And it also means that you can have API calls of any duration, which is what we are talking about here, because there is no really difference if it takes 100 milliseconds or 10 weeks, because it's still API call, because my process is still there. It's we'll wait for that reply to come back. And one kind of, for example, just a very direct use of this long API calls, you can just have a sleep. You just sleep for like 10 days and you go to the next line of code. So durable execution is kind of the abstraction which will help you to write much simpler code in a lot of scenarios. And going to the APIs, the coolest part is that when you call something which is not durable execution, so just any existing API out there, and it can fail, or network connection can fail, other bad things can happen, we do retries. We talked about retries. But as durable execution cannot fail, retries can be as long as necessary, and you don't lose context. So it's just normal retry. The same thing if you put queue in the middle. You can put queue, you can do retries. From the API point of view, it's still the same. So think about developer experience of calling something which uses queue, uses exponential retry, does any other like failure recovery logic, doesn't change if you have durable execution as a client. So just to recap, durable execution is a way to keep business logic clean from failure and recovery concerns because they can be hidden by the underlying infrastructure, and all these retries don't affect your developer experience. You still just invoke a function. So it provides seamless persistence, so you don't need to persist your state explicitly in a database because all your state is always persisted. And you can support invoke synchronously almost practically any function, and it takes as long as necessary. So my claim is that durable execution is actually the best way to build resilient distributed systems. Okay, I talked to you about abstraction, and looks like magic, it's all cool, right? Like, okay, what it's all about. Reality is that I present project, it's open source project, MIT license, so I'm not trying to kind of say you have to pay me right now. But temporal.io, temporal been around for 6 years in production. I and my co-founder of the company started that at Uber as a project what was called Cadence. And it's been in production for 6 years at Uber, and then a bunch of other companies, like some logos are here, use it in production at large scale. And it was built from beginning for a very large scale, so you can have hundreds of millions of parallel, like these processes running. And it's pretty resilient and so on. And it has SDK in every language. So when I talk about durable execution, it doesn't mean that you need to learn new language. It doesn't mean that you need to have some DSL. It is just normal language. So if you're a Java developer, you just write Java code. So you will use Java syntax. If you type TypeScript, it will be TypeScript. If you're PHP or like Python, you just you use that. That is kind of the basic idea. So we used a terminology of workflows because kind of the way it started, it has its roots in the simple workflow from Amazon. And people kind of know what workflow means. So practically the idea is that we have workflow, which is code, and this is this durable execution. And then the main restriction is that workflow cannot make API calls directly to external systems. It does it through activities. So activities is any function which practically implements whatever business logic you want, but it's not durable, but it can be retried. Right? So for example, you can call external service, it will be automatically retried if necessary. And then workflow code is that durable function code which will run for a month or 3 weeks or whatever. So one example would be if you want to do subscription, you can write code like for loop 0 to 12, sleep 30 days, charge customer, send email, and it would be production code you would write. That is kind of workflow you would write. And let me make it a little bit more concrete. I'll just show you some real code. I don't know. I don't have much time, but I probably can run some demo. Oh. That is nice demo. Just a second. Let me go to presentation mode. And I cannot even read this. Not good. Just a second. How do we change resolution? Demo always interesting. So this is actual production code you would write. So in this case, we doing transaction. This is like one way it's also very useful to do sagas, if you've heard about them, because it's easy to do compensations because there is guarantee that code will keep running. And if you do withdraw to deposit, it's kind of next best thing after like after real transaction. And in this case, if you look at the account, it's there we define what we call activities. This is just normal Java interface. And again, we have SDKs, different languages. And you would just implement it any way you want. It's just your code, whatever. But when you invoke it from the workflow, you just create what we call stub, passing the class and options. And options just define retry options and like timeouts and all these things, because these things are automatically retried by the system. And then you just call those operations. And that is how you would practically do that. And it's totally normal to go and write like workflow sleep 30 days in the middle, and then we will run these 3 lines of code for a month. Or practically use any Java logic, object-oriented design, and so on. Let me see if I can run that. I've got 4 minutes. Okay. So if I request, for example, a money transfer, practically calling just started that workflow. I run right now the system locally on my machine. And the idea also that this is not that we run this code, like the open source project doesn't run this code. It's you run this code, usually it's your kind of code. It just needs to connection to the backend server. So it's not like you need to change your deployment procedures. If you deploy to Docker, you will use Docker. If you deploy to bare metal, you deploy this code to bare metal. Here, I will run it inside of debugger directly in the IDE. So if we check that, it started this workflow and it's completed. And we see every step of that. So it started from started, like we see that withdraw activity scheduled, and inputs of that. It doesn't have output, but it will see output as well. And then you will see the other activity started and so on. So it's useful, but not that interesting. But let's say we go and introduce bug in the activity. Let me redeploy it, which is just restarting process in this case. And let's start that. Oh shit, it's a wrong one actually. Wrong example. Let me do it. Oh, it's there. This is what happens when you keep stuff running before the demo. Okay, let's run it again. So we run this. We see this running. We see nothing happen because I actually didn't start the code which hosts the workflow code. So if I start that code right now, we can go to UI and track its status. And we see that it's actually scheduled withdraw activity. And then withdraw activity has these arguments. And if we restart that, now we see that actually withdraw activity completed, but it's scheduled deposit activity. But now we see deposit activity is failing, failed 4 times. And this is last error it had, which is I just introduced as you saw. This is like was simulated error. And you see stack trace. We probably need to format it better here. And then what I can do, I can just go and fix that activity without restarting my workflow. So let me fix that. Let me redeploy it. And then if you go and check this workflow status, it says that it should retry pretty soon. Yeah, we see this workflow completed. And we can go back here and say, okay, this workflow, this activity ran 10 times, and this was last failure, but then it completed, and it will have result. It's void, so it won't return that. So probably think about it. You can have code in production, millions of those things running. You have any problem, you have a bug, you can just fix by deploying new code. And they just keep running as nothing happened. And deployments, like any different like types of applications and so on. And it's like scratching the surface. But main idea, this one thing I didn't demonstrate. First, activity can retry for a day, and you still invoke transfer call, and it's blocked there. So it's API call, just one API call. Also, this activity can be another child workflow. It can run also by itself. Its logic can be very, very long running, because it can heartbeat and so on. So probably your APIs, instead of this fully asynchronous, like event sourcing, whatever, becomes just like normal services, how you would do them normally. But they are, okay, that was actually me saying myself that 20 minutes passed. Yeah, but that is kind of the idea how you do. You can practically write services like they're synchronous, but they underneath they're absolutely synchronous. Obviously, I didn't have time. We have Booth here. Just by this exit, we can go into the details there as well. And any questions?
Okay, Maxim, you talked about it being an open source based project.
Yes, it is 100% open source MIT license, both server and the SDK libraries. So you can run it in production. Like we have a lot of customer users of the open source, like Datadog, HashiCorp, Coinbase. They all run open source still, 100%. Our monetization as a company, we have company now 3 years, started 3 years ago. We run these backend servers for you. It's fully consumption based. So it means that if you run whatever, and it's relatively cheap. So it starts adding up when you start hundreds of thousands of workflows per second. Then it starts adding up to real money, but then it provides a lot of value. So I think it's $20 for million actions or something like that. It's cheaper than step functions. Which I kind of people compare that. It's probably problem with like things like step functions is that they until certain complexity they work. Beyond certain complexity they don't work because you just hit the wall with features. This is code. You can code anything, like even step functions. Like you can interpret step functions and provide DSL. If you're building DSL, you can build it on top of that. Yeah.
Any questions on that? What were some of the interests here in this presentation? Did you get what you wanted from it? Anyone who's tried this or experimented? When you're finding, some of your clients or some of your users, when they're starting, what sort of like that, that threshold, they don't need to be at that step function level of complexity yet. What's a good entry point? Or so for members of the audience, if they're thinking, oh, should I give that a go or not? What would be like some of their situation that you would say they're the ideal level to be using this?
Okay, do I care about losing data or not? Am I okay for losing data? Am I okay my process getting stuck and whatever? If they are not, then probably should start with that. It is very easy to start. Like I showed you sample, it's like 5 lines of code. It's actually running sample. If you're using like our cloud service, you practically can just need to specify connection to that certificate, and you can get it running like within minutes. So startups love us because it makes the experience like building applications much faster. But because it was built for Uber and there are a lot of companies running that at a very large scale, largest scale probably which runs in production against our cloud service is Snapchat. Like every Snapchat story update is a workflow. And these guys, especially right now with football, soccer going on out there, they have pretty interesting spikes. So we can run to very high rates. So it means that if you're a startup, you're successful, you don't need to change your code. And that is kind of very big value proposition they have. But it's very simple to start. It's not like this is for complex products. It's simpler than step functions. I'm giving them as example because people use them and they can understand their pricing range.
Oh, one question here. Thanks.
Hi, like the technology seems pretty cool. I have a question regarding how does that play with like multi-region support or like multi-data center support?
Yeah, so that is an awesome question. So we already multi-AZ and whatever, so you can just deploy it on top of a replicated database like Cassandra, and our cloud service does this as well. We also have very awesome feature when, again, I don't have time to go in details, but we actually have application level replication. So you can have 2 clusters or 3 clusters in absolutely different regions, absolutely independent, running in different type of database, different versions. And we do replication, and then we do reconciliation of conflicts if necessary. And you can do failovers within seconds from one to another. And I don't think anyone has that because we can do it also per namespace because these clusters are multi-tenant, which means that you don't have blast radius problem. Any database which you distribute across regions, like single command can screw up schema or whatever, and you lose availability. People like think about regions, but they say they still deploy solutions which with a single command can break. With us, with our like multi-region replication, it's impossible because these absolutely independent clusters doing application level protocol. So yeah, if you need multi-region, talk to us. We have a very good story there.
Okay, fantastic. And you'll be out here at your
yes,
booth?
Just get out. The second booth is ours.
Okay,
Temporal.
So, Maxim, thanks very much.